Hello everybody, this is Michael. In this video, we will talk about the ESP8266 NONOS SDK UART Hello World, development. We will have three things. So the first one is go through the SDK folders. The second one will be UART Hello World coding. The third one is compile, download, and test. Okay. So let's go for the first one. So in previous video we have this folder, and we already use this SDK, and we could I will delete it. Okay, I delete it, and then let's unzip a new one. Unzip a new one. Okay. So this is a new one, entire new one. As we mentioned it before, this is a share folder with our Ubuntu VirtualBox in the Linux, for the Linux. Okay, so let's go through the SDK folder here. So this is SDK folder. Take a look. So which folder we will need to change, and the folders for what purpose. Okay, so let's take a look at the first one. This is bin. So it is the compile will generate the bin file. It will put all here. So of course we no need to change anything under the bin. Okay, this is document. Actually there is no any document here. It's just a readme, and you will see they ask us to go through the chip company website to see the document. Okay, so the third one is driver library. The driver library is put all the driver here. So you will see GPIO, hardware timer, I2C, key, SDIO, SPI, and the UART. Okay, so this is provided by the company, and for us to use it. And basically it's just a write and read register, and setting the chip different function like I2C, SPI. Okay, so this is include folders. This is for the all head file. Okay, this is for all head file. So this is driver library. This is example. So this example to tell us how to use chip on the application level. This is AT. Okay, and this is LITO demo. So basically what we need to do is working on this folder and change the files, under this folder. What we will do is each folder will be an examples. Each folder will be examples, and then we need to do, let's say we will do the UART hello world communication with the computer. Okay, we will do is like a copy this folder and go up and paste this folder here, and then we rename it. Let's say we rename it UART test. Okay, So we will change the file under this folder and then compile it, but we will do it for the next step. Okay, so let's continue. So this is example folders. It's very important and for us to create our customized application. And this is include folder, and you will see here. So all the include file here. Yeah. So you want to use one of function, you need to include this head file. Okay. So this is include folder. This is link folder. What mean link folder? When you compile the files, you will get the object file, and the link tool will, according the link file, link the folder together, link the object file together to be a bin file. Okay. So of course we no need to change this. We no need to change this at all. And this is library folder. Okay. You will see there's a lot of library here, and this is SSL, and okay, this is WAP. So and the chip company already put most of the code into the library, and you will see this is LWIP for TCP/IP communication. This is Johnson. Okay. Put all the source code in library, and they will automatically loading the function from the library. No need for us to change it anymore. It's a very good benefit. We no need to see so many detail, and we just need to change our special application code will be enough. So for this folder, we no need to change anything. And then for this folder, this is open source folder. This is set part, and you can see some source code here. So this folder is the open source. You will be able to read all the source code under this folder, but you no need to change it either. Okay, this is a tool folder. So this is Python. So they use the Python coding to handle some compile processing. Okay, and this is UART test. This is just a we copied from the example folder from here. Copy this folder for our second step. UART hardware coding. Okay, and this is license make file. From the folder structure, you will see it's very simple, and we just need to copy one of this example folder outside to his parent folder, and here, and change the name and change the code under it, then we'll be fine. Okay, let's go to the second step, the hello coding. UART hardware coding. Okay, so under this folder you will have an include folder, include head file and the user folder. Okay, and then we go inside the user folder. So this is make file, and there is SPI test, and this is user made. Okay, user made, they if you have tried any microcontroller before, you will know they will have a main function. It is the entry of the whole application source code. It is a start point. It is a start point for the coding. Okay, so this file is the main user main file. It will be have a start point for our application. So let's open it. And I will recommend it use this Visual Studio Code to read all the code. So this Visual Studio Code is coming from the Microsoft, which is open source, and also you will see it's very beautiful. The color is very beautiful, and it's very simple. If you use it more, you will like it more, and I like it very much. Okay, so this is user may .c. Okay, so this is our user application files. Let's take a look here. You will see the whole file is very simple. It's the simplest code system. Let's say from the hardware system design, you will have the minimum, as we discussed it before. You will have the minimum hardware system. For software, we also have the minimum software structure. Okay, this is a minimum software structure. Okay, so this is the entry user init. Okay, this is the entry of the user application. So this application, the original file is test SPI interface. Okay, we don't need it, so we delete it. And so then we'll have two functions here. This is for the Wi-Fi RF Wi-Fi signal calculation, and this function is for prepare the Wi-Fi signal. Actually, you can close the Wi-Fi signal here and in the function. The benefit of it is you can save power, because for some application you no need to power the Wi-Fi RF when the system power off, because the microcontroller can collect data by itself and can get the sensor data back. At that moment, at some point, we don't need to connect the Wi-Fi. We only need the Wi-Fi when we want to transfer data. We send data to PC. We will need the Wi-Fi. If we don't want to pass the data to computer, we can power off it. Okay. So these two functions actually, in the earlier version, like a 1.5.2 version, the simplest software didn't have these two functions, and only have this function. Okay, so only have this function. So the most simple software structure will only have this function interface. Okay, so it's very simple. For the latest version, they open this and this function for the RF control, for the Wi-Fi signal control. It will be more flexible, and for our test, we keep it untouched, and so it's not related our test. We just want send the UR hello world to computer by UR to test the UR function. Okay, in this video. So we already removed the SPI test. So this is SPI test head file. We also can remove it. Okay, so this is a SPI test function. We copy one function from it. So let's take a look. We just copy this thing. Okay, we copy it to here. Okay, so we remove this. And we change this. Change this to hello world. Okay, hello world what? Let's say from micro studios.com. Okay, so we just change a very simple code. We added one nice simple code here. Okay, we save it. Oh, that's it. We keep all the thing untouched. We keep all other things untouched. We added one line coding here. Okay, so next step. So we finish this one. So it's very simple, right? And then next step, we compile, download, and test. So as we show it before, we use VirtualBox. We use the VirtualBox. We use the Ubuntu on the VirtualBox to compile the software, and the software is in the share folder here. Okay. Remember, so this user test is we copied from here. The example code we copied from these folders. Okay. Now it's time to compile. So 1, 2, 3. We already changed the password in previous video. Okay, unlock the system. Okay, so let's go it one by one. So we needed, if you first enter here, you need to use the mount command. You need to use this command to mount your share folder into the Ubuntu system. Okay, so 1, 2, 3. Okay, so you will go to the share folder. Okay, and then list. So go into this folder. Okay, so we list. So you will see here the UART test. So this folder is our created. We copy another folder from the example folders and change the name. Okay, so we list it. We will use this command to compile it. So let's use this command. Enter. Okay, so this asks us step 1, choose the boot version. So for the previous video, we don't explain what's meaning about this, but for here, we will explain it. So the first choice, choose the boot version or not. The boot version is from Wi-Fi to update the firmware. Then if you do this, you will need the boot. If you update the firmware from the UART, you don't need it. So at this moment, we will update the firmware from UART. So we choose 2. Okay, we choose 2. 2 means none. So we no need boot. Okay. Okay, step 2. Choose bin generate. So if you use still if you want to update the firmware from Wi-Fi, you will need two bin. It's user 1 bin and user 2 bin. But if you update from the UART, so you no need both of them. So at this moment, we choose 1. Okay. So step 3, SPI speed. We want the SPI speed as fast as possible, but if for the higher SPI speed, there is two conditions. One condition is flash will has to support this higher speed. The second, the PCB layout will be satisfy the requirement of the speed. For safe, we choose 2. We choose 2, and it is 40 megahertz. Okay, we choose 2. Then step 4, choose the SPI more. And so this tool is for the this 4 is for the different SPI connection to the flash. They need the hardware supported, and you will find in this web link it describe this SPI more in very detail. Let me show you the web page. Okay, you will Google these tools, and so ESP tool wiki. This is from the chip company. It's a tool to download the bin file and how to write the bin file into the flash. But you will see here the SPI flash mode. So here there is a very detailed description for the how to choose the SPI more. Okay. So we will choose, when we compile at this moment, we will choose this one. If you want to know, because this one is you will take a look here. And you will take a look here. So in this mode, and this mode is 5% faster in this than this mode. Okay, so let's continue. So here we choose this mode. Okay, so it's 2. So we are using the ESP01 hardware. Okay, we are using this hardware. So so we using this hardware. Okay, as we talked before in the previous videos. So we use this hardware, and you will notice for this hardware there is 2 versions for the SPI flash. For our mode, the SPI version, the size is 2. Okay, the size is 2. So we choose 2. Okay, it is compiled. That so no boot need, and it generates this flash bin and it generates this wrong text. Okay, so this is the address. Okay, So let's take a look. It's generated or not. Okay. So when it generate, it will be the bin file under the bin file. Okay. So yeah, this is timing just update, and this is another file. Two file generate out. Okay, since it's already generate out, and we will to try to download it. Before we download it, we needed to connect the hardware. It need to be the different from the working mode. We needed to connect this pin to ground. Okay, connect this pin to ground. If you watch our previous video, we don't connect this pin to ground, and okay, so connect the or the connector according this schematic, then plug the USB to the computer. Then we will use this tool to try to download it. Okay, and we will use these tools here. So this tool you can download it from the official website, the chip company website. Okay, so you click here, then it will show the screen like this. Okay, so we use this one, so we click this one. Wait a moment. Okay, it show up. So then we'll have 5 files needed to download it. So you will find it in the document. Let me show you the document. Okay, you will need this document, so you can find it in the chip company's website. And then we go through here. We go through the downloading. Okay, chapter 6. Okay, download. Okay, so we already opened these tools, and we need to go through here. Oh, sorry, we go through, I'm sorry, it should be, yeah, it should be here. So should be here. So this is not update from the Wi-Fi. Okay, this firmware. So we need the actually is 4 files, 1, 2, 3, 4, and this two is exactly the same, but we need a certain address according to this one, because this our flash is 1 meg. Okay, 1 meg flash. We need setting a different address for this one, and these two is the bin file which we compile it getting from our source code. So this is the first one. Okay, let's take a look at the tools. Okay, so you will see this is the first one. So this is first address, and this is the second one. This is the second address, and this is the third one. Okay, blink. This is the third one, and this is 4. Okay, this one, this file. This is the last one. Okay, this is the last one. This is the last one. So where you can find it, you can find it in the bin folder, and we already compile this and this. So this blink is default over there. So when you download and unzip the SDK folder, you will get it. It is already there, and this file is also over there by default. Is here. We choose this one. When you unzip it, it will be over there. So for the first time, you need to choose 5 of them. You need to choose 5 of them. After you finish your first try, you no need to these 3 anymore. Okay, so we just choose all of it. Okay. Anytime you choose all of it, it will be good. Okay. So we need to change a little bit about the flash. So first one is crystal. This crystal frequency is decided by your board. Our board is ESP01, so the crystal is 26 megahertz. And when you design the board, it's already fixed. Okay. And the SPI speed is 40 megahertz. As we mentioned it before, when we compile the software, we already choose the 40 megahertz. Okay, and this SPI mode, when we compile it, we also choose this mode. Okay, and the flash size, so it's 8 megabit, which means it's 1 megabyte. Okay. Okay, you plug your hardware and connect the module like this, and then we'll be okay to download. Okay, let's try. Oh, we need to choose the command port. So here is 6, and the setting the baud rate is 6. Okay. So we start. So you will see it's already downloading. Okay, so finish. So means it's done. When it finish, it will read the flash. When it download, it will read the flash information here. Okay, so and also give you the MAC address for the AP mode. And this is for station mode. This is 2 MAC address for your modules. Okay, when it finished done. Okay, next step we will test the modules. Okay, and so we need to open. We need to disconnect this pin, and also when you open the as you know, we use the real time. We use this to communicate with the port. Okay, so first we disconnect this pin, and in our module is here. So this red one, we disconnect it. Okay. So the next step is to open the PC UART is here. So choose the baud rate. Okay. As you see here, we just print the string out from the hardware UART. We didn't setting the UART baud rate, and for the hardware, the default battery will be this one. The default battery, it will be this one, and this is decided by the crystal. 13 is 26 megahertz, and if we need to change, like use this one, we will setting it. So this will be next step. We try this first. Okay, we try this first, and the last step, we will disconnect this one and then reconnect it again. This is working more pin. Okay, again, let's try it. Okay, let's try. Our pin is here. It's this one. Disconnect and connect. That's it. Okay, you will see. Okay, so you will see that the module already output the information from the modules, and it print this string out from the module, which is exactly our printed out, right? Okay, so means we already can control the UART. Okay, but you will see here, this is the battery. The battery is very unusual. If we want to change the battery, how we do it? Okay, so let's change. Let's take a look at the source code again. Okay. So this is a bin folder. The driver will be under this folder, and this is a UART folder. If we want to change the UART 13, let's take a look. They have a UART init. Let's find it. Init. Okay. So you will see here, we find all of it. Yeah, that's it. So this is UART init, initialize the battery from the to UART. Okay. So what we need to do, the first thing is, okay, we copy it. We change it here. So we change the battery 112520 and okay. So now we change the battery, and so next step we need to include the head file. So where is the head file? Okay, the head file, let's take a look at. This is the driver, right? And this is the include folder. And let's go. So this is the include folder also. And okay, we will see here include under the include, we will have another folder name is driver. So this is files head files. We copy this and we replace this, and we need this folder's name and slash. So you will ask, why we including like this will be fine. Why we don't including this folder either? We don't. Why we don't write this name of the folder? The secret is here. You will take a look here. This is a make file. we open it, take a look. So this is a makefile, and this chip uses Linux style to compile the source code, which is using the makefile. And you will go down at the bottom here. So you will take a look here. So this folder's name already be included into this variable. This is a path variable, which means all the folders path, the system will automatically to search all the folders under the folders. Okay, so you will see our driver library include is already being setting into the including path. Okay, is already setting here including path. So for our source code, what we need to do is just including the subfolder's name will be fine. Okay, so for this thing we do two things. One is including the head file. Another thing, we added the UR initialize here. So if you added the UR initialize, if we setting the UR baud rate like this, and after this moment, this string print is only will be print out and see under this baud rate. Okay, so let's try it. The first thing is also, of course, we need to compile it, right? So okay. So we still use this command to compile it. At this moment, we choose to no boot, and this moment we choose 0, and this we choose 2, and this we choose 2, and this we choose 2 again, and the read will be compiled. If there is any error, they will pop up and show us in which file and which line. So there is no any error, successful, and this one, these two already be compiled. And let's download it. Okay, let's find our tools. It's here. Okay, so we need to stop this first, and then we need to open this again. Okay, it's here, and we use this, connect it, it will be here. Okay, so for this time we don't need to download these three of them, I'm sorry, 3 of them, and we just download 2 of them, and these 13 keep untouched. And at this moment I needed to plug the cable again, which is here. So okay, so I needed to connect this pin. Okay, so now it's connected. Okay, and then we needed to set in the common, and then everything is done. Start synchronize. Okay. Okay. it cannot synchronize, so we disconnect the module and then plug it again. Okay, so there is synchronized error. We unplug the module, we plug it again, and then okay, so this is already done, and so at that moment I connected a wrong cable, so here should be these places, is not here. Okay, so now it's done, and let's power on it. Close this one. Close this one. And last time I connected this pin, and instead of this, so it's always say cannot sync. So I connect here, so it can be download. Okay. So let's open the real time. To connect here, setting the port, and open, and then disconnect this pin, also this pin. Okay, we need disconnect two of them. Yes, disconnect this pin first, and then disconnect this and plug it again. Okay. Perfect. So you will see our print already printed out and under this boundary. But before this, before this strings is all cannot see cannot show the correct strings here, because before this the boundary is still the old one, so this will cannot be decode, cannot be correctly decode. Okay, so that's it. This is SDK UART hello, and it is a bit longer, and I hope you like it and help you. And I'm Michael, and thank you very much. Thank you for your watching.